Hello, my fellow students and chemistry learners all over the world, students that have been following me. Okay, this is a question on rate expression and rate law. So write the rate expression and rate law for the following reaction. If you want to understand what rate expression and rate law means, you can go to my previous video, okay, on chemical kinetics, on rate expression and rate law. Okay, I have videos on that, so try and watch it before you can be able to answer this question. I'm going to do A and B, and I will leave one for you to do. Okay, so if we want to write the rate expression, okay, for this reaction, our rate expression will be that rate is equal to the disappearance, I hope you have not forgotten, the disappearance of the change in the concentration of iodide ion, okay, to the change in time, okay, is equal to the disappearance, okay, of the change in the concentration of OCl minus to the change in time is equal to the appearance and the change in the concentration of Cl minus with time, and equals to the appearance, okay, of the change in the concentration of OI minus with what now? With time. This is the rate expression for this reaction. Okay, that is the rate expression. And if we talk about the rate law or the rate equation, okay, rate law is equal to, okay, remember, go to my video on rate law and look at it. It is, you talk about the rate constant to the concentration of iodide ion, the concentration of iodide ion, okay, the concentration of OCl minus, okay, this gives you the rate law for this reaction. Okay, the rate law is usually directly proportional to the concentration of the reactant raised to the appropriate power. Okay, and the power in this is the coefficient of the reactant. Do you understand that? You go to my previous video and learn about that. Okay, then for B, I will do A and B, then you will do C. Okay, for B, you can see the coefficient 4, 5, 4, 6. Those are the coefficients. So for our rate will be equals to, okay, the disappearance of what? This. Meanwhile, you have 1 over 4. The change in the disappearance of the concentration of ammonia, okay, with time, with the change in time, is equal to the disappearance. You see, this 5 will come to the denominator. Just watch my video, you will understand better. Okay, the concentration of oxygen with the change in time is equal to 1 over 4, the concentration, the change in the concentration of nitrogen 2 oxide with time, okay, is equal to 1 over 6, the change in the concentration of water with time. Okay, so that actually answer the rate expression for this reaction. I mean, then rate law, as I told you, is an empirical equation. You have your rate constant, then the concentration of the reactant, okay, raised to the appropriate power, which is 4, the 4, the power is 4 here because that is the coefficient you have here. Okay, then is this case you have the other one, oxygen raised to the power of 5. You don't put plus, you don't put minus. Please, following the law of mass action, it is a product of the concentration of the reactant, okay, or their masses raised to the appropriate power. Okay, I want to believe you quite understand this question. So you are allowed to do this and put your answer in the comment section. I know that you have an understanding. So if you do, ensure you share this video to other students in secondary school, elementary school, and to higher institutions, undergraduate students all over the world, so that those who have been having problem in chemistry will be reformed by this video. Thank you. Your chemistry tutor, Akweji Honesty.